All right, so let's learn about how to balance chemical equations. Remember, when we're balancing chemical equations, we need to make sure that our products and reactants are equal to each other on both sides. What that means is that our number of things on the left side is equal to the number of things on the right side, or you could think of this arrow as an equal sign. And so the number of atoms on the left side, so carbons, hydrogens, whatever elements we have, has to be equal to the things on the right side. And so whenever we do this, we have to do this because it's the law of conservation of mass, which just means that things cannot be created nor destroyed within a chemical reaction. What that means realistically is that atoms can't just appear out of nowhere, and they also can't just disappear out of nowhere. And so our job whenever we balance chemical equations is to make sure that that is always the case. And so let's go through an example of this where we have, let's say we have NaCl plus MgO, and that turns into Na2O and MgCl2. And so whenever we balance chemical equations, my first step usually is to assume that we have one of something that looks a little bit more complicated. So assume one of something complicated. What I mean by that is something that has more than one of each of these elements, right? So in this case, NaCl is just one Na and one Cl. MgO is just one Mg and one O. While on this side, we have Na2O, so we have two Nas for every one oxygen. And we have MgCl2, so that's two Cls and one Mg. And so I would classify the right side of this chemical equation, either one of these two, as a complicated molecule. And so I just assume that we have one of those. And so let's say that our first step, let's say we have one of these. What would that do in terms of making sure that we have things balanced on both sides, right? And so what I like to do is calculate how many NAs and Os we have based off of how many we have in front. And so I like to color coordinate this so that's a little bit easier to follow. So let's use yellow as an example. Let's count how many NAs we have on the right side of this chemical equation based off of one of these. And so what I do, it's always you multiply what we call the coefficient, or the number in front, by its subscript, or the number down below. And so in this case, it's 1 times 2. That is equal to 2. And so on this side, we have 2 NAs. And then we also have oxygens as well, but we won't focus on that until we make sure that we have the same number of NAs on both sides. And so if we have 2 NAs over here, that means we need to have 2 NAs on the left side. And so how do we make sure that we have 2 NAs? Well, the easiest thing to do is let's say that we have 2 of these in front. So that's 2 times, remember there's an implied 1 right here. So 2 times 1, that is equal to 2 NAs. And so we have the same number of NAs on both sides of this chemical equation, and so we're happy. But that also factors in and changes how many of our other elements that we have. And so in this case, we have 1 times, remember this is an implied 1 right here. So 1 times 1, that is equal to 1 oxygen. And so we need to have the same number of oxygens on both sides as well. Thankfully, our molecule over here is just MgO, so 1 oxygen. And so we just need 1 MgO. And so that would be 1 times, remember this is an implied 1. 1 times 1 is equal to 1 oxygen. And so we have the same number of oxygens on both sides, and so we're happy there. But now we have other elements like Cl and Mg that have been affected over here because we've had 2 of these and 1 of these. And so let's calculate how many Cls and Os we have on this side. And so let's do other colors as well. Let's go to a darker blue for Cl. So 2 times, remember this is an implied 1. 2 times 1 is equal to 2 Cls on this side. And then on this side as well, let's do a orange color. So we have 1 times, remember this is an implied 1 right here. 1 times 1, which is equal to 1 Mg. And so on our left side, we have 1 Mg and 2 Cls. And so in order for us to have this balance where we have the same number of things, we should just have one of these, right? So that we have 1 times, remember this is an implied 1. 1 times 1 is equal to 1 mg. And then let's look at our CLs. So we have 1 times 2. So 1 times 2. That's equal to 2 CLs. And what do you know? We have the same number of CLs on both sides. We have the same number of Mgs on both sides, which means that we have balanced out this chemical equation. And so the balanced chemical equation will be 2, 1, 1, 1, so that we have the same number of things on both sides. That is all you have to do every single time you balance chemical equations, is just making sure that your elements have the same amounts on both sides.